Assalamu alaikum, dear students. We are discussing this system of linear inequations. Today, we will discuss few more, questions, problems on this. Now, the first one is solve graphically this system of linear inequations. The system is x plus y less or equals to 9, y greater than x, and x greater or equals to 0. So here we have three linear inequations. Now we will draw the solution region, or we will find the solution region of these three inequalities. For x plus y less or equals to 9, we draw the graph of x plus y equals to 9. That is the straight line x plus y equals to 9. That is this is x plus y equals to 9. Clearly this region R1, that is the region below this line, is the solution region, which is denoted by R1, as well as the points on this line represents the solution region of this inequality, because you can check it by considering 0 0 belongs to this R1, and 0 plus 0, when we substitute in the given inequality, it is 0 plus 0, which is 0. It is less than 9. So this means that the points in this R1 as well as the points on the line makes the given statement as a true statement. That is why this R1 is the solution region. Similarly, by considering y greater than x, this is actually x minus y less than 0. So we have to solve actually this very inequality, x minus y less than 0. In order to solve this, we draw the graph of x equals to y, that is x minus y equals to 0, which is this line passing through origin. Now clearly points on this side or the solutions, or simply the points on this or the solutions of this very inequality, because x minus y is less than 0, but not the points on this line x equals to y, because here we have strict inequality. So this means that here it is the region R2, which is the solution region of y greater than x. Similarly, x greater or equals to 0 means the positive x axis. Positive x axis, that is this first quadrant. Now the intersection of these three regions is simply the region, this ABCA, that is closed region ABCA, but not points on BC, because if we consider BC points on this line BC, this means that these points should satisfy these three inequalities. So they simply satisfies the first and the last inequality, but not y greater than x. That is why we have to consider, or the required solution region is ABCA, but not points on line BC. So this is the required solution region as shown this shaded portion. Now we will solve how to solve double inequalities. If we consider 2 less or equals to 3x minus 4 less or equals to 5, here we have to find the value of this x. So here in this middle expression, 3x minus 4 contains minus 4 as well as 3 in the multiplication. So this means that our priority should be to remove these very terms. So how to remove this minus 4? By adding plus 4 on both sides. It is 2 plus 4 less or equals to 3x minus 4 plus 4 less or equals to 5 plus 4. That is 6 less or equals to 3x less or equals to 9. Dividing by 3, 6 by 3 less or equals to 3x upon 3 less or equals to 9 by 3, which implies that 2 is less or equals to x less or equals to 3. Here it depends upon situation. If x is real, this means that we have to consider, or the solution to this double inequality is the set of all real numbers from 2 to 3, that is closed interval 2 3. But if it is natural, or if it is integer, if x is integer, then it is solution, or this solution set contains only 2 and 3, because 2 and 3 are the only real numbers, natural numbers, which belongs to interval 2 3, closed interval 2 3. That is why if we consider x from R, then its solution region is this interval, closed interval 2 3. Similarly, if we consider this double inequality, 7 less or equals to 3x plus 11 by 2 less or equals to 11, by simply multiplying by 2 on both sides, it is 14 less or equals to 3x plus 11 less or equals to 22, because by cross multiplication you know it. Again, by subtracting minus 11, it is 3 less or equals to 3x less or equals to 11, or simply x less or 1 less or equals to x less or equals to 11 by 3. Now here this 11 by 3 is simply a real number or simply a rational number, and its value is 3.60 or 3.63, and this 3.63 lies between 3 and 4. That is, here this point is this x 11 upon 3. So this means that the solution region, or simply we can say that the solution of this double inequality is this interval, closed interval 1 to 11 upon 3. Now how to solve this? 8x plus 2y less or equals to 4, y greater or equals to 0, and x greater or equals to 0. Here 8x plus 2y less or equals to 4 can be written as 4x plus y less or equals to 2 by dividing by 2, because constant terms are even numbers. And how to solve it? By drawing the graph of 4x plus y equals to 2, that is this very straight line, and here we have less than equal to, which implies that this region R as well as the points on this line represent the solution region, or simply is the solution region of this very inequality. Similarly, x greater or equals to is this very portion, and y greater or equals to is positive y axis, and this is x axis, that is x greater or equals to 0. But the intersection of all these is simply this triangle, this very triangle. So this is the required solution region of this given inequality. So in this way you can solve single inequality, double inequality, or simply you can solve the system of linear inequations graphically, or simply a linear inequation graphically. So in this way we completed this linear inequations in two variables. Inshallah, from tomorrow onwards we will consider another chapter. So thank you.